Good day,
Hey,
YouTubers!
YouTubers!
I'm Tristan
And I'm
Cabangangan
Francis Tamoria. Today we will be teaching you guys how to illustrate the limit of a function.
using table of values and graph of a function. So, let's start with the symbol of the limit. So, this is the symbol of the limit. This is read as the limit of f of x as x approaches c is L. Mathematical limit describes how function values change as the x values change. So first, we will evaluate limits of function using table of values, and our first example will be 3 of x plus 5 as x approaches 2. In the table of values, we will be having a table with x and f of x on the first column. X for the value that you will be substituting on the equation, and f of x for the answer after substituting the x on the equation. For the x values, it should be closer to c but not more than 1 unit. If c is equal to 5, the x should only be between 4 and 6, getting closer to 5. For the given example, c is equals to 2, the plus sign indicates values greater than 2. So, x should be 2.001, 2.01, 2.1, 2.5, and 3. By substituting the x values to the given equation, we will be getting the f of x values shown in the table. 3 times 2.001 plus 5. And we get 11.003, and 2.01 we get 11.03, and 2.1 we get the 11.3, and 2.5 we get the 12.5, and 3 we get the 14. As the research shows, as x gets closer to 2, the value gets closer to 11, meaning the limit of 3x plus 5 is 11. Now, we'll be having c equals to 2, meaning we should be getting values of x less than 2 until 1. As we can see, the limit of the function as x gets closer to 2 is also 11. Thus, limit of 3x plus 5 as x gets closer to 2 in both sides is 11. And now, not all functions have equal limits. For example, limit of square root of x as x approaches 0. The x values are 0.001, 0.01, 0.1, 0.5, and 1, and their corresponding f of x are 0.03, 0.1, 0.32, 0.71, and 1. We can see that the limit of square root of x as x approaches 0 on the right side is 0. Next is the left side of the limit. Limit of square root of x as x approaches 0 on the left side. The values of x are negative 1, negative 0.5, negative 0.1, negative 0.01, and negative 0.001. The x values are negative, and negative numbers don't have real square roots, since a square is either positive or 0, so the limit does not exist on the left side. By comparing the left side and the right side limit, we can say that the limit of square root of x as x approaches 0 on both sides doesn't exist. And now, we will be having our next example. Limit of 2x plus 4x as x approaches 4 on both sides. The x values on the right side are 4.001, 4.01, 4.1, 4.5, and 5, and their corresponding f of x are 48.002, 48.02, 48.2, 50.2, and 70. And the x values on the left side are 3.5, 3.9, 3.99, 3.999, and 3.9999. and their corresponding f of x are 38.5, 46.02, 47.8, 47.98, and 47.99. As we can see, the approaching value on both sides is 48. And now, we'll be having our last and final example. Limit of 10 as x approaches 4 on both sides. The values of x on the right side are 4.001, 4.01, 4.1, 4.5, and 5. And their corresponding f of x are 10, 10, 10, 10, and 10. And the x on the left side are 3.5, 3.9, 3.99, 3.999, and 3.9999. And their corresponding f of x are 10, 10, 10, and 10. Since this is a constant function, we can say that the limit of the constant is the constant itself. Thus, limit of 10 as x approaches 4 on both sides is equals to 10.
Now we'll be evaluating limits using graph. When finding limits using a graph, you need to look at the x-axis. For example, limit of f of x as x gets closer to negative 5. This graph, we will be focusing on this graph. These two lines, as it gets closer to negative 5, the value on the y-axis, which also means f of x on the table of values, is negative 3. So the limit of this function is negative 3. Next example is limit of f of x as x approaches to 7 on the right side. So you can see we will be focusing on the graph, this graph, and this is the 7 on the x-axis, and on the right side, as it approaches to 7, the y-axis is equals to 0. So the limit of f of x as x approaches to 7 on the right side is 0. Now we'll be having the next example, which is the limit of f of x as x approaches to negative 2 on the right side. Now we will be focusing on this graph, and as we can see, there is a hole on the graph, meaning negative 2 is not included, but it's fine since we only need to find the limit as x gets closer to negative 2 nearer to the value. So as it gets closer to negative 2, the value of the y-axis is 9. So the limit on the right side is 9. Next is the limit of f of x as x approaches to negative 2 on the left side. Again, in the negative 2, this graph, as it gets closer to negative 2, the y-axis is 8. So, by comparing the two sides, we can say that the limit of f of x as x approaches to negative 2 on both sides does not exist because the two limits are not equal. Last example will be the limit of f of x as x approaches to 8 on the right side. We'll be focusing on this graph, and as we can see there, as the graph approaches to 8, the equivalent y-axis is negative 3. So negative 3 is the limit of f of x as x approaches to 8 on the right side. But if we will be getting both sides, the left side limit is negative 2. Then the limit of f of x as x approaches to 8 on both sides does not exist because both sides are not equal. This ends our tutorial on how to evaluate limits of a function using table of values and graphs.
Thank you for watching this video, and we hope you learned something from us. And we'll see you next time. Bye-bye!